me to start over?
Nah, yeah.
Start over. It's only basic, just talk. So this is problem 11 in section 16.3. Now, this is the answer we're trying to get because, well, it looks complicated enough. I know it's written sloppily. It's t to the t times 1 over t plus natural log of t plus natural log of t squared. All that plus 1 over t. So this is the problem. F of x to y equals x to the e to y plus y e to the minus x. And this is the RT, which is that. So we're applying the chain rule to take the derivative of that with respect to RT. So the first thing we did was take the gradient of f of x, y, which equals the partial with respect to x, which is x is your variable, so that means it'll disappear since this is a constant, so that's e to the y. Now x is your variable, so that'll be minus y e to the x I plus your partial with respect to y. So now it's x e to the y, which is the same thing, plus now y is your variable, so it'll disappear, e to the minus xj. Then we want to take the derivative of RT, R prime of t. Derivative of RT is 1 over ti plus the derivative of this. This is a product rule. So that is the first, which is first times the derivative of the second, 1 over t, plus the second times the derivative of the first, which is t, which is 1. So that'll be, this will cancel out, so that's 1 plus natural log of t. So r prime of t equals 1 over t of I plus 1 plus natural log of t of j. Is that right? That looks right. Yeah. So now we know what r prime of t is, and we know what the gradient of f of x, y is. I'm just going to rewrite r prime of t up here for future reference.
You done with that problem?
Oh no, this was long.
Oh, all right. Let it go.
Plus 1 plus natural log of t of j. So I'm going to erase this. Now we have to dot this with this. But we have to plug in RT, which is this, into here. So since this is your x and this is your y, you plug in natural log of t everywhere you see an x, and t natural log of t everywhere you see a y. So the gradient of f of RT equals e to the t natural log of t minus t natural log of t d to the minus natural log of t. Oh, that's the first term. I equals e to the t.
Can you rewind, like, just go back like 3 minutes and talk about what you just talked about? Because the tape went out. Just repeat the last thing you said.
Whoa.
It was every x replace it with LNT and every y.
Yeah, whatever. Just go back like 3 minutes. All right, go ahead, Warren.
Go ahead. Okay, so started from the top where
Look at the board and point it out.
Too much my CV.
Just explain sort of like what this algebra is going on right here, because that's what a lot of people get lost in.
okay.
If you want to write,
Probably not. Okay. So after we're finding the gradient of f bar of t, I believe we're plugging in to the gradient the values of natural log of t. Well, that we're plugging in r of t into the values we got for the gradient. Right.
Let's just talk about how we simplified the gradient.
Yeah, I'm trying to find like.
Is that a red star of t around space?
So you're talking about how we went from here to here?
How you move from here to here?
Okay. Oh yeah.
Yeah.
Okay. Well. So basically, because we're using natural log, you can bring the t up to the higher position, and so the e and the natural log cancel out, and you get t to the t. The same thing happens here because you bring the -1 to the top, and so the e, the natural log, simplifies that down to e t.
The E and the ln cancel out.
Yeah, the e and the ln cancel out.
That changed, like, that whole section changed to T, ln T, E to the ln T to the -1. So the ln and the E canceled out.
Oh,
And
yeah.
then so you had T to the -1, which canceled out the other
Which is t. Okay.
And you're left with ln T.
Yeah. No, Bessie. Okay. Yeah, so I mean, in case, so the e and the natural log cancel out, like she was saying, and you get it.
You write it down.
Huh?
Write it down. Probably easier to see if you write it
Okay. So you end up with t to the natural log t to the -1. No.
That's right.
Oh, it is? Okay, and so then, but then wouldn't you, so it's like 1/t
Times t, which is just 1.
Okay. Yeah, but then like, well, yeah, we're missing
Oh, you forgot
No, you forgot to
you
write
forgot
it.
another t.
that T. Okay.
No, that's a natural log of t.
Natural log of t, then t to the.
Yeah.
Okay, that's right. So then,
Nah.
Nah.
Yeah.
The movement
oh, it's
is
on
one.
the inside, yeah.
Yeah, there you go.
So then,
Yeah.
those two cross out and you end up with this.
Yeah.
And then down in this part, you kind of have the same thing happening. This E and the natural, well, this T goes up here, right? Yeah. So then the E and the natural log cancel out, and you have another T to the T times natural log of T, which is what you get here. And then this one just cancels out to,
The negative goes up above the T.
yeah, the negative goes up above the T up here, and then these cancel out.
Yeah.
So you have a T to the -1. Yeah, which is the same as 1/t.
In bacteria.
Right. Thank you very much.
Nice. Did you get it more now since you had to tell me?
Yeah.
Now I was real sick, man. So, I'm gonna erase this part.
In the, I think it's the bubble. What is?
That's the answer.
Okay.
We looked at the problem and we looked at the answer. It was like, dude, how in the world did they get that? So we want to make sure as we're working it out, we're somewhat getting closer to that answer.